I forgot to tell you, I'll take your homework questions on 10.3 tomorrow instead of today because everyone will actually be here tomorrow. Okay, so that's why I'm not taking them. Okay, this talks about conics in architecture. We studied parabolas, ellipses, and hyperbolas. The fourth one is circle, but we've already studied that. We just studied that outside of this chapter. And so this goes through like several different, it names some stuff here and then goes through several different examples. Some of them are kind of cool. You might have been to the U.S. Capitol and seen the ellipse. I think that's where the whisper spot is. Like you stand at one foci of the ellipse and you can like hear the other if you whisper. What? Yes. Mm-hmm. I haven't been there, but I'm pretty sure that's the same place. And I think like this is ugly. I don't know, but it looks like what we graphed yesterday. So I don't know. You might have seen some of these things, but there's some examples. There's a lot more. It just gives you 6. I told you Friday I will expect you to know different examples. There was some here. There's been some spaced out through the other sections. Yeah. It's like where it focuses on. And so on our graph, it doesn't really do anything, but the application part is normally at the foci. That's where like the planets would be or the comets would be or like things like that. So for us, like for the actual graph, it doesn't do much, but that's where the application part comes in. I'm going to let you look at that on your own. Okay. This is not a new concept to you because we did it with circles. You remember what the equation for a circle was? X squared plus y squared equals 1 was if it was centered at the origin and a radius of 1 or the unit circle. Give me the generic one. That was for a circle. That is the other conic. That is a conic. And what was the center for this? Bless you. What'd you say? Okay, I did too. So, HK, and I didn't hear him, and that's all I heard. Center is HK. Remember, it's the opposite signs. Okay. So if it was like -2 and -3, your center would be 2, 3. Not unusual, right? Change the sign inside the parenthesis for your center. We're going to do the exact same thing for the center of the ellipse, the center of the hyperbola, and for a parabola. So we're not going to have center. What are we going to have for a parabola? We don't have a center. Vertex. So we're going to, same thing though, it's going to be the same type thing. And here it goes through which way it moves opposite, right? But you know that X moves left and right, Y moves up and down. This goes through an ellipse. This is the formula we talked about. How do I know this is an ellipse and not a hyperbola? The plus sign, right? It would be negative. One of them would be negative as hyperbola. This was centered at the origin. This is centered elsewhere. I'm at HK. So that's where you'll see those. And we just moved it over. So let's do that. This is an ellipse. We have a plus. What's our dominant axis? Y. Why? Bigger. Yes, it's Y because 9 is bigger. Okay, for an ellipse, you go by the bigger one. For a hyperbola, you go by the positive one because the positive is bigger than the negative one. So it's Y dominant because the 9's under the Y. What's A? 3B. Okay, what is the formula for finding C for an ellipse? Minus, right? It's plus in the equation, so it's minus here. The hyperbola was opposite. So in this case, that is 9 minus 4, and what is C? Okay, so we have ABC. From here, we would normally list our vertices and foci. I want to wait and do it after we graph because that's going to change because our center changed. What is the center for this? -1, 2. Got to change the sign on both. Are you with me on all of this? The good thing about this section is it's a review of everything we've done so far. Okay, so that helps. Like, literally, this is all that's on your test. Friday will be parabolas, hyperbolas, and ellipses. Yeah. Because of the formula, they're always minus on the inside, and it's in parentheses, so when you pull it out, it's opposite, just like with the circle. So you will always change the sign on both of them, always, okay? So there's my center. You're going to have to flip to graph. It asks us to determine the coordinates of the foci, but I want to do that after we graph. Okay, so it was centered at -1, 2. And really what we need to know is our ABC. I'll recopy them because I'm sure yours is on your own page. Sorry, I know. Rough stuff. Okay, so there's my center, and then I do everything the same way as normal, except normally I do it from the origin. Now I do it from the center. Okay, so which axis was dominant? Y, so is it going to go up and down or left and right? Yeah, up and down. So A, 3, go 3 up, 3 down, but from the center, not the origin. All right, so same thing we would do at the origin, but we're doing it off our green dot instead. And then good, yeah, use your B, go 2 left or right. And there's our ellipse. That's not bad, right? Normal. Just shifted a bit. Okay, now let's graph our foci. It's going to be hard to graph. Square root of 5. What is that in decimal form? 2.2-ish, 2.3, which one? 2.23, okay. So I'm going to go up and down from the green dot. Okay. Problems graphing. Questions? It's pretty much the same thing we did. Now, I think the ending part can be a little bit more confusing. Like a teeny bit, maybe. You got it. So now we want to determine foci, but we don't want to use the 2.2 because that's inaccurate. Okay, we're going to use the square root. So you could come here and you could like approximate, right? This is -1, -0.2, and -1, 1, 2, 3, 4.2. Okay, but let's do it accurately. Well, it's on our Y. So we're having to add in our center. Basically, you're going to take your center, and for foci, what letter would we normally add in? C. Normally, we just do 0 plus or minus the square root of 5. Well, we're going to take our normal foci, which is that, and we're going to add it to the center. And you don't even have to write that out if you don't want. But we're going to take what would normally be our foci, and we're going to add it to the center. Because the center is shifted. It's not at 0, 0. Normally it's off of 0, 0. This time it's from -1, 2. So the x-axis doesn't change for either one. The y, because it's y dominant, we add it to the y. So you're going to have 2 plus the square root of 5. And 2 minus the square root of 5. You could do square root of 5 plus 2 and negative square root of 5 plus 2. But that's it, and you just leave it like that. Those are your foci. Well, we already graphed it, but you would convert it to a decimal, right? So this would be like 2.2, so that would be -1, 4.4. Questions? Does that make sense what we did? Everything's the same. You just have to add the center to it. So we didn't find vertices, but if we would find vertices, we would use plus or minus 3 on the y, but then we would add our center to it. Yeah. No. You have to write this out, yes. This would be your answer, but you don't have to write out the work. But you will have to write it out with the square root form to get the correct answer. Now, if it asks, don't write everything out if it doesn't ask, though. Like, it didn't ask me for vertices, so I'm not putting them. Scott. Yes, but foci goes off C. And so the foci is the yellow dot here, so -1, 1, 2, 3, 4, 2. That's right. Does that make sense? Good. Okay, let's do another one. We're going to talk about parabolas. We said it's the same thing, but instead of going off the center moving, the vertex is moving. Now look at these forms. when we did them in class, we divided and had 4p on bottom. In the denominator, we're going to have them in top here, okay? But you have the x minus h squared, 4p y minus k, depending on which one is squared. P was that focal length. So the distance from vertex to directrix, vertex to the focus. Okay. There's no C for parabola, but it's like instead. Determine the vertex, focus, and directrix, and sketch the graph. Okay, let's sketch the graph first. What's squared here, x or y? So it's going to be like an x squared, so it's going to open up or down. This looks nothing like our equation. Right, if you look up here, because I have this x and this y, and that's not okay. I need an x minus something. All right, over here I need like an x minus h squared. Now we can get the right side to look like that by factoring, but my left side does not look like it should. It has an x squared and an x, and I need it factored into what? What could you call this? It's a square. What's that called? Perfect square. I need it factored into a perfect square. Thank you. It took us about 10 minutes for Spirit to arrive at that question, that answer. Yeah, if you need a perfect square, you need to complete the square. Okay. So we do need to complete the square. It's been a while. This is the one where you leave the blanks. It's super quick though. And we have to leave the blank on both sides, right? We got to add it to both sides. And remember, our goal is to factor this into something squared. So b over 2 is what we're going to use. What is our b here? So negative 4 over 2 is, that's what goes down here, right? And then you take the negative 2 and square it, and what do you get? And that's what goes up here. And you can check, is negative 2 squared? That would be a negative 2 times a negative 2, which is a positive 4. Negative 2 plus a negative 2 gives us the middle term of negative 4. That's right. And then we combine the right side, 8y, with negative 28 plus 4. Okay. So what it factors into goes down. And then the actual square part is what we use at the beginning. Okay, now that right side, you need to get the y by itself so that you can find the center. So what do I need to do? And what do you get? No, it still needs to be there. Now, you could divide by 8, right? But you'd have to divide the other side, but that would have it in the form we looked at the other day, which is totally fine. From here, we need two things in order to graph. What is the center? Sorry, parabola. What is the vertex? What is that 8? So what is P? Okay, so P is 2, vertex is 2, 3. Bless you. That's what we need. P is 2, vertex is 2, 3. So I'm going to go to 2, 3. That's my vertex. Which way is it opening up if it was an x squared? Up. So if it's opening up, where do I go to find my directrix? Down 2, because P is 2. And it's opening up and the directrix is below it. Yes. Above it, right. My foci will be here. And then how far wide does it go? From the foci. How far am I going to go from the foci, left and right? 4, y? 2p. Were you here for lesson 1? That's why. Yeah, this is always p. This is p. This is 2p. This is 2p. The whole width should be 4p. Always. Like, that always happens. Right. Okay, I'll let you finish copying that down. questions.